0,
1,
1,
2,
3,
5,
8,
13,
21,
34,
55.
89.
This is the Fibonacci sequence. In fact, this is a series where a number is found by adding up the two before it. Starting with 0 and 1, we make the sum of these two numbers and we obtain 1. Then 1 plus 1 equal to 2, 1 plus 2 equal to 3, etc. Written as a rule, the expression is xn equal to xn minus 1 plus xn minus 2. This sequence of Fibonacci's number arises all over mathematics, in art, and also in nature. But how and by whom has it discovered?
Who is Fibonacci? Leonardo Pisano, better known as Fibonacci, is the greatest European mathematician of the Middle Age. Born in 1170 in Italy, he was one of the first people to introduce Indo-Arabic number system in Europe. The young Fibonacci traveled a lot with his father and received the opportunity to study mathematics in countries around the Mediterranean coast. Back in Italy, he published Liber Abaci, which became a very popular work in mathematics. Many mathematical concepts appeared after Fibonacci. Also, during the Middle Age, his work in number theory was almost wholly ignored. He died in 1250 and there is now a statue commemorating him located in a cemetery next to the Cathedral of Pisa.
How has Fibonacci his sequence discovered? In his book, Fibonacci described his famous sequence with an experiment on the reproduction of rabbits. His problem is the following one. A man puts a couple of rabbits in isolated places. How many couples do we obtain if in 1 year every couple engender a new couple every month as from the third month of his existence? The answer of this problem is this schematic. In fact, 1, 1, 2, 3, 5. This is the Fibonacci sequence. The Fibonacci sequence possesses numerous properties very used in mathematics. One of them is that the quotient of two consecutive numbers of the sequence approaches phi, represented as the golden ratio. It is equal to 1,618 and more exactly 1 plus square root of 5 divided by 2. In fact, 13 divided by 8 equal to 1,625. 21 divided by 13 equal 1,61538 and so on. The more we move forward in the Fibonacci sequence, the more the quotient of two numbers aims toward the value of the golden ratio.
Fibonacci in nature. The Fibonacci numbers are nature's numbering system. They appear everywhere in nature, from the leaf arrangement in plants to the patterns of the florets of a flower, the bracts of a pine cone, and the scale of pineapple. The Fibonacci numbers are therefore applicable to the growth of every living thing, including a single cell, a grain of wheat, a hive of bees, and even all of mankind. Indeed, the sunflower seed pattern used by the National Museum of Mathematics contains many spirals. If you count the spirals in a consistent manner, you will always find a Fibonacci number. Furthermore, each seed is 137.5 degrees from the other seed, and 137.5 degrees is the value of the golden angle. Also, other flowers, like the rose, have Fibonacci or the golden spiral in her petals arrangement. Fibonacci and animals. To explain you that, I'm going to give you two examples. Example 1, The Nautilus. The shell of the chambered nautilus has golden proportion. It is a logarithmic spiral. Example 2. The dolphin. The eyes, fins and tail of the dolphin fall at golden sections along the body. Fibonacci and humans. Humans exhibit Fibonacci characteristic too. The golden ratio is seen in the proportion in the section of a finger. 1 thumb in each hand. 2 bones in one thumb, 3 bones on each finger, 5 digits on each hand, 8 fingers in total.
The Fibonacci spiral and the golden ratio are frequently used in art, mostly in paintings, monuments, or even photographs. The golden ratio gives an aspect that seems to be aesthetically pleasant for the eye. In monuments, the golden ratio is the golden thing the most used. We can find this ratio, for example, in the CN Tower in Toronto. The ratio of the total height and the height of the observation deck equals the golden ratio. Other monuments are also built with the same golden proportions, like the Great Pyramid of Gizeh, Notre Dame de Paris, some Greek temples, and lots more. In paintings, the golden spiral is preferred. Many painters use it to create paintings which have the subject not aggressively put in the middle of the painting, but instead on one side or another according to the spiral, like this painting of a wave from Okusai. We can also find multiple spirals in only one painting, like the Birth of Venus, painted by Botticelli. The Fibonacci spiral is even more present when the artwork completely follows the curves of the spiral. And I can take the same example, the painting of Wave, painted by Okusai. The golden number is everywhere. We can find it in arts, nature, and even in the daily life. This mathematical property seems to be known since many years. Even the Egyptians used it. We don't really know why we can find it everywhere on Earth and even beyond, but maybe someday we'll know. But don't be fooled. Some people that use the golden number too much can find spirals in like every painting, every artwork. For example, if you crop the spiral, resize it, invert it, you can find a perfect match in every artwork. So I try to do that and look at all these beautiful spirals.